On the 20th of September 1911, Titanic's sister ship, the Olympic, was steaming down the Solent.
The Olympic is about to set off for her 5th voyage across the Atlantic, and she's sailing through the Solent parallel to a Navy warship called HMS Hawke.
And they were having a bit of a race, so there was a bit of fun going on between the two ships.
Due to the restricted channel, the Olympic tried to manoeuvre out of the way of the Hawke, but it was misjudged.
The Olympic effectively cuts up the Hawke, and he couldn't stop a collision.
The Olympic, like the Titanic, featured a series of internal bulkheads dividing the ship into watertight compartments. Even though the warship had punched a hole in her side, the bulkhead compartments prevented water from flooding the whole ship, allowing her to stay afloat.
I think the spectacular survival of the Olympic from the Hawke collision planted a dangerous idea in people's minds.
If a warship can take you on and you can just sail home again and get fixed, then it's giving people the wrong idea.
Many would have thought, well, that really does make the ship relatively unsinkable. Invariably, most captains operating on a transatlantic voyage will want to go as fast as possible in the early part of the voyage to have something in hand in case they encounter fog. Fog is very prevalent on the North Atlantic, and it generally means you have to slow down. So by going faster at the beginning, you have something in hand just in case you meet the unexpected fog.
Smith would not have been unduly worried by the iceberg risk. 7 months earlier, he'd been captain of the Olympic when she survived a serious collision.
If you are Smith and you have captained Olympic and she's survived being rammed by a scary-looking spike on the front of a Royal Naval vessel, then you are not going to be that concerned about what a little iceberg might do to you. Because in your mind, if there's a big iceberg, your people are going to see it and steer away from it.
No doubt the perceived risk of striking an iceberg was so small that it was discounted. But there was the very real risk. If the ship arrived late in New York, there would be a lot of adverse publicity.
Titanic's fireman revealed that a fire had taken hold in the coal bunker in Boiler Room 5.
The fire had been going since Belfast, when Titanic would have sailed with a skeleton crew round to Southampton to make the voyage.
So when the Titanic left Southampton, the fire was already there?
The 3-story high bunker was only finally emptied on Saturday the 13th of April, 1 day before the collision.
Fire was burning for something in the region of about 10 days. It took that long to actually empty the bunker.
The sheet of steel that formed the bunker's rear wall did another critical job. It was part of a watertight bulkhead, the safety feature specifically designed to stop the ship from flooding if she got a hole in the hull.
What 2 of the surviving firemen actually said was that once the coal was taken out of bunker number 5, that you could see how the bunker had warped because of the continued heat it had been exposed to.
So the warping of the steel plates may have weakened one of Titanic's vital watertight bulkheads.
We know from the inquiry into the Titanic disaster that the intense heat of the bunker fire on the Titanic had actually deflected the metal of the hull. And this meant that there was no longer a perfect seal, and in fact the fire-damaged plates in the bulkhead may have been weeping about 1 or 2 buckets of water per hour, even before the collision.
To be a wireless operator on one of these big transatlantic liners, you had to be really good at your job. You had to be really swift at sending and receiving Morse code.
As well as incoming passenger messages, the operators received urgent safety alerts from nearby shipping. They were marked with 3 letters to highlight their importance.
MSG, Master Servicegram, was a priority message that was intended to be sent to the captain, and it was used for things such as ice warnings and the like.
Several ice warnings from other ships earlier that day were marked MSG and were duly relayed to Captain Smith.
Captain Smith saw and received all these messages, so he decided to go a little bit further on, about half an hour additional travel before turning west towards New York.
While Smith entertained first-class passengers to a 10-course dinner featuring oysters and filet mignon, in the Marconi room, the messages were piling up. At 9:52 p.m., another ice warning arrived. This one from the SS Mesaba, a few hours ahead of the Titanic, heading for New York on almost exactly the same course.
Saw much heavy pack ice and a great number of large icebergs. Also, field ice.
It was a clear warning that Titanic's new route would take her straight into an ice field bristling with giant bergs. But the message never reached Captain Smith.
The problem with the Mesaba message is that there was no MSG prefix.
Almost an hour later, Titanic received an even starker warning from a ship just 10 miles away. But again, the three critical letters, MSG, were missing.
At 10:30 p.m. on the night the Titanic sank, so only an hour before the collision, a vital message came in from the nearby Californian, who radioed the Titanic to say that they were stopped and surrounded by ice. Now, unfortunately, right at the moment that it arrived, the wireless operators on the Titanic were really busy doing what's called working Cape Race.
Titanic was trying to communicate with Newfoundland over 400 miles away, so it would have had its radio set switched on to a very high level. The Californian, fairly close to the Titanic, when it sent out the message to the ship, it would have come through extremely loud.
It nearly blasted their ears off. So the Titanic replied, "Keep out, old man," which meant, "Please be quiet, we're busy." And sadly, with that, the operator on the Californian went to bed. If you look at this glass of water here, as the pencil is behind it, what you can start to see is the different shapes that are being made. And that's simply because light is bending according to the density of the water behind it. And this was the same the night the Titanic sank, because the air was different densities, and therefore the light was bending. Everyone has heard of a desert mirage. Well, this actually created what we call a miraging haze at the horizon behind the iceberg. So in effect, the haze on the distant horizon actually camouflaged the iceberg in the near ground.
Lookouts Fred Fleet and Reginald Lee have no idea that they are staring into an optical illusion.
If they'd had binoculars, theoretically, they could have seen that base of the berg a little bit earlier, and those few seconds could have been crucial for Titanic.
Titanic's central propeller gives its rudder more power to change direction, but only when it's rotating.
Crucially, when the order was given to stop the engines and then latterly reverse them, the center propeller would have been stopped.
Cutting power to the central propeller would have stopped it pushing water across the rudder for a few crucial seconds.
We're talking about a marginal situation here. And perhaps the rudder, working a few percentage points more efficiently, may have swung round just a little bit more to actually miss the iceberg.
Instead, Titanic struck the giant berg.
A rivet is a way of fastening two sheets of metal together. You would take this rivet and heat it up and then put it in through a hole that was punched through the two pieces of metal that are lined up on top of each other. And the rivet is put in through that hole and then hammered at the flat end, and that deforms the flat end into another head and fastens these two pieces of metal together.
These rivets hold up well under normal circumstances, but the North Atlantic was unusually cold that night.
Because Titanic was cutting through smooth, icy waters, her hull would have actually been below freezing at the time of the collision.
But that's not all. High-quality steel rivets could only be inserted using a bulky hydraulic machine, which in the bow section was a challenge.
The hydraulic riveter was a very, very large, unwieldy piece of equipment. Where the hydraulic riveter was not so efficient was in the parts which are not straight, the turn of the bilge, or in the bow of the ship, where the hull is more angled. As a result, you had to use manual riveting crews there.
But steel rivets required too much force to be hammered in by hand. So the plates of the ship's bow section had to be fixed together by rivets made not of steel, but iron. And iron had significant drawbacks.
Wrought iron is not quite as versatile as steel, and when it's made in the smelting process, it produces a byproduct called slag, which is just all the stuff in the ore that you don't really want in your iron.
The slag in the rivets can make them even more prone to fracture when struck by a heavy force in low temperatures.
As the iceberg hits the Titanic, that force and that impact has to be absorbed, it has to go somewhere, and it's going to impact the weakest sections of the ship that it's hitting, and those are along the seams, along the rivets. So the ship basically gets unzipped and water floods in, and we know what happens after that.
After the collision, the Titanic came to a stop, and people wondered what had happened. So their natural reaction was to open the portholes and have a look.
As the ship's fate became clear, the crew ordered passengers up on deck, ready for evacuation.
And then, when they went up to the lifeboats, they left the portholes open. As Titanic's passenger accommodation began to dip under the Atlantic, the open portholes meant that water flooded in at a much greater rate. In fact, 12 open portholes would have doubled the iceberg damage to Titanic. And of course, there were hundreds of portholes in Titanic's bow.
Standing an average of 12 meters high, the bulkheads weren't tall enough to reach the passenger deck level. A deliberate choice by Titanic's designers. Once the water reaches the top of the bulkheads, they become useless. Water spills over them, flooding all the compartments, and rampages unchecked through the public spaces above. It's the final straw. Titanic's bows dip below the surface, hoisting her stern high in the air.
In the final moments, there were thunderous crashes as the steel was heard down below to be breaking apart at the keel level. And then higher up, there was almost a stampede of passengers towards the stern of the ship.
She rises so high in the water, and then she seems to right herself again, and people think they're saved. Everything might be all right briefly, but all that is the stern snapping off and falling back down. You have all-out chaos in the final death throes.
The lights went out, and then the ship bobbed for a bit, and then disappeared forever.
The Titanic's foremost bow section was a collision bulkhead. Like the crumple zone in a modern car, it was designed to absorb the worst of a head-on impact, protecting the integrity of the compartments behind and reducing the inflow of water. Scraping the underside of the ship along the iceberg arguably caused more structural damage than a head-on crash. But Murdoch could never have made that call.